In the name of God. Hello everybody, this is Zeinab HAZBAVI from Iran with my team workers from Iran and also from Montenegro. Decided to do a research entitled Up-to-Date Assessment from Soil Erosion of Northwestern of Iran. As you know, the soil is one of the valuable natural resources of human beings. And in this regard, different soil management practices are suggested that mainly included 6 methods that are a proper use of amount and type of soil tillage, soil organic matter conservation, maintenance of suitable nutrients for plants, prevention of soil contamination, soil acidity balancing, and soil erosion control. That is the focus of our study. The soil erosion is one of the most important issues in the world. Soil erosion is a type of non-point pollution that can increase the river's sedimentation, pollute the water, affect the floods, threat the vital ecosystem services, and reduce efficiency of electricity projects. Various models have been proposed regarding the physical process of soil erosion. One of the newly introduced models is the intensity of erosion and outflow, that is abbreviated to INT-ERO. The INT-ERO is a new graphical model that has user-friendly software and can provide a complete view of the components of watershed erosion. This model has recently attracted the attention of many countries due to its simplicity and ability to manage large data sets. For example, SPALEVIC et al. In 2014, Barovic et al. In 2015, Khaledi Dardishan et al. In 2018 studied the soil erosion process in different sub-watersheds using INT-ERO model. They finally verified the performance of this model. This end, the sub-watershed 2, which located in the Kuze Topraqi watershed, as you see in the map, was selected as a case study to predict the soil erosion characteristics using INT-ERO model. The total area of this sub-watershed is estimated about 8.44 square kilometers, and the perimeter is about 14 kilometers. The average elevation is about 1,436 meters. The INT-ERO model is basically developed based on EPM, that you see the relations that usually used to develop EPM method. But this model, in addition to EPM, is incorporated with geometric, climatic, topographic, hydrologic, and maximum outflow variables. This model uses 26 simple and wide available variables as inputs. For the present research, all primary maps for study were processed and provided in the ArcGIS 10.6. Then, according to the required standards of the model, the data bank was provided in the Excel 2016. As mentioned before, the geometric and topographical data is used as the first layer into the INT-ERO model. We use the digital topography map with a scale 1 to 25,000 to calculate the geometric and topographic variables. The subset of these variables is shown here. Second layer is included geological data that is that is formed by very permeable, medium permeable, and poor permeable regions that symbolized by FP, FPP, and FO in the graphical model of interero. In our study, we use the geological map of 1 to 100,000 scale. The hydrological and the meteorological data are two important of this model. In the hydrological data, we calculated the total length of the main water course with tributaries of 1 and 2 degrees and the shortest distance between the fountain and mouth. And from the meteorological data, we computed the volume of the torrent rain, average annual air temperature, and average annual precipitation. In addition, data on the soil erosion intensity was extracted from previous studies that conducted by ALAEI et al. In 2019 and 2020 for Pozzo-Toprogli watershed. Finally, after running the interero model, 22 components related to the soil erosion process was obtained. The results show that the climatic characteristics, including average annual air temperature, is about 9.16 centigrade degree, and average annual precipitation is about 330 millimeter. The temperature coefficient of the region was calculated equal to 1.01. Furthermore, the geological data showed that the structure of the sub-watershed is very permeable, so the coefficient of the region's permeability was calculated by about 0.4. The analysis of the vegetation and land use data also showed that the 90% of the sub-watershed is under floodplains and only 10% is covered by mountain pastures. So coefficient of the sub-watershed planning was calculated about 0.87 and coefficient of the vegetation cover is about 1. Furthermore, the variable of Z coefficient of 1.28 indicates that the sub-watershed belongs to one destruction category. The strength of the erosion process is excessive, and the calculated maximum outflow sub-watershed is 7.67 cubic meter per second. The production of erosion material in the sub-watershed was about 12,919 cubic meter per year. The coefficient of the deposit retention is estimated at 0.087. Real soil losses at the sub-watershed outlet was computed about 1,124 cubic meter per year, and the real soil losses per square kilometer was estimated as 133. In the conclusion, we can say that the current study was conducted to provide an up-to-date assessment of soil erosion in a sub-watershed located north of Pozzo-Toprogli watershed, Ardabil province in Iran. The results proved that the maximal outflow from the sub-watershed is 7.67 cubic meter per second for a return period of 100 years. The value of Z coefficients also indicated that the sub-watershed belongs to the second construction category out of 5 categories. The production of erosion material in the sub-watershed was about 13,000 cubic meter per year. The strength of the erosion process is estimated strong, and the erosion type was mainly from surface erosion. So finally, this study confirmed the other findings in the successful implementation of the Intero model in Iran. The Intero model could be a useful tool for researchers in the calculation of runoff and sediment heat at the level of the subwatershed. Thank you for your attention and goodbye.